Now, all we need is to give them some wonderful noise, but it's looking promising. Now let's get on with the noise. So with the noise, we need the resample help. Let's create a curve view attribute that's gonna help us map the amount of noise that we apply to the curves, the new curves. We're not going to be using the same trick of using the tips, of not applying the noise to the tips. We need something a bit more more of a gradient, a bit more subtle. Let's create point VOP. Noises tend to be a bit easier with this. So let's call this electric noise. Let's type inside. We need the curve view. So let's grab a bind. Curve view. Let's have a ramp parameter. This is what's going to help us map the amount of noise we have. So we have the curve view that's going to be connected here. This ramp is going to be a spline ramp. We can set the default to be something. Let me set the interpolation to B spline. Put this around here, one around here, and something like this. So kind of an arch by itself. And once we have this, we can create some. What should we use? We can use. Let's use the usual. So let's go with the anti-aliased noise. We'll use the vector to vector 4, where we grab our position and our time. So now we have a 4D vector. Wonderful anti-aliased noise. And we're gonna go with this here, and let's say 3D noise, and we'll add this to our position. But not before it's actually multiplied by this ramp. And then it's outputted. Now, from this noise, let's expose frequency, offset, amplitude, roughness, all these. And we should be good to go. Now, this ramp doesn't have the default shape that I just created, so you can just control middle mouse button on it and it'll have it. Then as for the values we're going to be working with, it needs to be really small and kind of electrical, feeling like very electrical. So 20, 20, 20. And here maybe 3. And the amplitude much smaller, so 0.1. 0.1 seems enough, and the roughness 0.5 seems okay. Let's see how this is looking. Pretty electrical, I would say. Not a lot of detail, so it's just a matter of going to the resample and maybe lower this down a bit more. Okay. I think the maximum value here on the push out is probably too high, so let's lower this to 0.8. Bit smaller, and maybe here we can go with 3. Okay. Then we have our electric things going on. We don't need to worry about them animating the introduction of that effect, because it's dependable on the density, and density is going to be growing according with the hit and the propagation of the energy effect. So that's going to be matching pretty well. And now we have this. Even though this seems like something that's being simulated, the only thing that's being simulated are the seed points. Very basic simulation. It runs pretty much real time. And then we're just applying some calculations to get a second point, connect the two pairs of points, and applying some push out effect, and then some extra noise on them. You can layer this, of course, if you want to kind of have something that's a bit with let's say bigger scale too, and then an amplitude maybe I would say 0.12 maximum, and then we can have a second one that does the same thing, but it's kind of you split it in big, and then you have one that's small. And based on the small, we can go up to 24, 24, 24, put this at 4, and maybe offset it on some axis, reduce the amplitude to 0.04, and maybe the roughness 0.6 on the small one. And you get some kind of a addictive effect, though we do need to make sure that we do have enough points so you can resample again here with nope, 0.005. So we have a lot of new points. Straight edges is fine in this case. We do need it to calculate the curve view again, just because we're going to be using it in here. So yeah, you can make this more complex and with a bit more interesting motion. Again, if you want to test these things, it's probably easier if you just do the time shift and go back and then go forward again. It's not updating, or it is, but it's just that I am looking at the robot that's animated. But all we want is kind of just see if the motion is interesting enough. And I think it is. We have a lot of complexity in here, so should be fine. Okay, and these are our electric arches. Let me just put a null here. Null out electric arches. These are going to be really cool elements to interact in terms of lighting and interact with the scene. Yeah, really cool. So on the next one, we're gonna move on to adding some sparks based on the trajectory of these electric arches. Okay, where occasionally one of the tips will actually generate some sparks. So really cool.